Welcome to question 5, and we start off, as you can see, with my sketch of an axis. That's because our first question is a sketch question. So let me write it out a little bit larger so that you can see what we need to sketch. We need to sketch this y equals x times by x minus 2 squared. So how can we go about determining what that looks like, or deciding what that looks like? Well, we can try and write it out slightly longhand. So if we not times out this bracket, but write it out as x minus 2 twice, and write this x as an x plus 0, then it might help give us a kind of better idea of what we are dealing with. So we can tell that because we have 3 x's, we have an x cubed, which means it's going to come up past this x-axis, go down again, and then continue up to probably infinity. And what we're looking for really is what points does it cross the x and y axis, because that's what the marks are for. So the first thing we can do is say that, right, well, we have an x plus 0, so it crosses at 0, x is equal to 0 there. And then we have another 2 x minus 2's, so if there was 1 there, then it would cross at the point x plus 2. But because there's 2 of them there, it doesn't cross the x-axis as much as kind of touches it and moves on. It doesn't actually go into the negative, it just touches the x-axis and moves up. So let me see if I can sketch this. I'll use purple to try and sketch this. So we have our 0, and it's worth saying as well that we know for y that it touches 0 at y, because firstly because this is x is 0 here, so it kind of must be, but also because we don't have any, like a plus 9 on the end of here or anything like that. We don't have any constant at the end, so let's get rid of that and see if I can sketch this. So up through 0 and then back down, and it's going to just flick this x-axis and then go upwards to infinity. So something like that, where obviously this point here is the origin, that's 0, and this point here is going to be the point 2 there, that's going to be x is equal to 2, and this is just our function. That's what we need to do. We can label it if we want. We can say y equals x of x minus 2 squared, but that's all we need for the 3 marks there. So that's that one done. So part 2, part II. So show that it can be expressed like this. Well, this shouldn't be too difficult, especially for 1 mark. So all I'm going to do is, as was here, I'm going to just write it out longhand. So we're going to have y is equal to x, and then I'm going to times out these 2 brackets. I hope you can follow what's going on. So x times x is x squared. Then I'm going to have minus 2x minus another 2x, and minus 4. I'll put plus there. Minus 4x, and minus 2 times minus 2 is plus 4. And then to finish it off, we have y equals, well, not to finish it off actually, but y is equal to x, hang on, show that it's this. I put a y there, that shouldn't be a y. Let me cross this out. So cross that out, make this equal to 3. There, make that equal to 3. So we have x times by x squared, which is x cubed, minus 4x squared plus 4x is equal to 3, and then take 3 from both sides. So I shouldn't have put a y there, this was equal to 3. So x cubed minus 4x squared plus 4x minus 3 is equal to 0. So you probably got that anyway, you don't really need me to explain that. Let's move on to the next one, and maybe I can get this right. So we have a polynomial bit, we have a polynomial part to our question, which is the same function, this purple line here. Find the remainder when it's divided by x plus 1. So how can we do that? Well, we can use our remainder theorem. Remainder theorem says if we have any, let me just write down a random x plus 16 you'll never see that, but if we have an x plus 16 and we want to find out what the remainder is, then we do p of minus 16. If we have x minus 10, then we do p of plus 10 to try and find out what the remainder is. So in this situation, if I rub out those because we've run out of space, get rid of those. So let's move to my blue colour. So let's draw a line under that. So our remainder when p of x is divided by x plus 1. So we are going to do p of minus 1 to see what our remainder is, and that means we're going to put x in minus 1 in, where all those x's are in the question. So we're going to have minus 1 cubed minus 4 times by minus 1 squared plus 4 times by minus 1 minus 3. That's what we're going to have there. So bear with me while I do the maths here. Minus 1 cubed is minus 1, then minus 1 squared is 1 times by minus 4 is minus 4, then take away another 4 there, and then minus 3. So what is that going to give us? That is going to give us minus 12, unless I'm mistaken. Let me go down slightly. Go down here. So equals minus 12. So that is the remainder when p of x is divided by this x plus 1. And then we need to use a variation of what I've just said, which is the factor theorem. Show that x minus 3 is a factor. So the way that we do that is take this minus 3 and do almost the exact opposite of what we did before. So let's take plus 3, put it in p of x, and if x minus 3 is a factor, then p of 3 will be 0. So we're trying to prove that p of 3 is equal to 0. Let's do that then. Let's do that. So part II here. So we are trying to prove that. So let's do it. Let's do p of 3. P of 3. So that is going to be equal to 3 cubed minus 4 times by 3 squared plus 4 times 3 take away 3. So let's have a different colour. Let's have this screen. I'm going to go down a little bit. I hope you can still see the question up there. So that's going to be equal to 27 minus minus 4 times by 9 is going to be, so minus 36, and then plus 12 minus 3. And then what's really important here is, so that you don't lose marks, try and make it painfully obvious that all of this, I mean, we know from the very beginning that it's going to be 0, but try and make it painfully obvious. So write something like equals 39 minus 39, which is equal to 0. And then for the mark as well, that's what we've done there, is 1 mark. The second mark is for saying therefore x minus 3 is a factor. So that's for the second mark there, because the first mark, I don't know how difficult you find it, but it's really not too bad at all. So let's move on to the next question. Let me scroll back up a bit so that you can see this properly. So express our p of x in this form with an x minus 3, so that's one of our factors, and some other quadratic, some other x squared in there. And there's a few ways you can do that. My way, or the way that I choose to do it, is long division. So let's draw a line under that. Long division. So what I'm going to do is say that I'm going to have x minus 3 here, and then divide my p of x. So what is p of x? So let's go back up a little bit. My p of x is going to be x cubed, so right in here, x cubed minus 4x x squared plus 4x minus 3. So when I divide, just to be clear, when I divide my p of x by x minus 3, I will get that x squared plus bx plus whatever they were looking for, that quadratic basically. So what am I going to do first? So I need to find out what times by this here is going to give me x cubed. Well, I think that's going to be x squared. So that's going to give me x squared times by x minus 3 is going to be x cubed minus 3x squared, like that. Then draw a line there and do a simple subtraction. So let me do a new colour for that. So x cubed minus x cubed is nothing, so I can even write down nothing in there if I want. And then minus 4x squared, take away minus 3, so plus 3 is going to be minus 1x squared, and then these two here just drop down and remain as they are. They're effectively 4x minus nothing and minus 3 minus nothing as well. So let's do exactly the same with the next step. Let's choose green for the next step. So what are we going to have then? Well, we need to find something times by x to give me minus x squared. So that's going to be minus x. And then do this minus x times the whole thing. So minus x squared. And then minus x times minus 3 is going to be plus 3x. And then exactly the same, draw another line, hopefully yours is straighter than mine, and then do the same again. So minus x squared, take away minus x squared is going to be 0, I'm not going to write it. So then plus 4, take away plus 4x, take away 3x is going to be x, and this minus 3 carries down here, and then look at that, they're the same. So we can put a plus 1 on there because 1 times by this, and then x minus 3 in here, do this, and it's 0 and 0. So that there, up there, that is, if we go back to the question, that is what we were looking for from here. There we go, that's our x squared plus bx plus c. So that is what the answer is for that question. I'm going on a bit too long here, this video is getting too long. So this final question, so hence show that this equation has one real root. So every time they say real root, you know what they are talking about. They are talking about the quadratic equation. So if I go down, if I'm going to use some space here, so the quadratic equation, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a with a straighter line. Now the bit that we're interested in here, or the bit that I'm interested in, is this part here. So this b squared minus 4ac, that bit there, that has to be positive, to give a real root there. So if it's negative, then you have the square root of a negative, which is a number with, it's a complex number, and you get into all sorts of different mathematics there. So show that the equation has one real root and state the value of that root. So we have an x minus 3, hang on, let me go up a little bit. We have an x minus 3 here, and we have a quadratic here. So let's put the quadratic's values into this b squared minus 4ac, this one that we have down here, and see what we get. Because if we do that, so if we say b squared minus 4ac, well, what's that going to be? If we look at our quadratic, so we have an x squared, a minus x, so a is going to be 1. Let me write this down. A is going to be equal to 1, b is going to be equal to minus 1, and c is going to be equal to 1. So b squared minus 4ac is going to be minus 1 squared, which is 1, then minus 4 times 1 times 1, So that's going to be 1 minus 4. So that's equal to minus 3. Minus 3 is, I know it's kind of obvious, minus 3 is less than 0. Therefore, this part here, this quadratic here, this has no real roots, because you have no answers for x there. It's not a real root, it's a complex root. So you'll do complex numbers later in maths, or maybe you've already done them, I don't know. But this part here, so this part here has no, sorry, not that part there, I'm lying. Let's go back up. This part here, this purple part that's now being done in blue, this part has no real roots. So our only one real root comes from x minus 3. Comes from x minus 3. So if we go back up to my graph here, basically we have a point where it cuts here. I mean, it's not here, but we have a point where it cuts, and we have another point that just, say that this came up here and it didn't touch the x-axis at all, it just came here and then went back up. So basically it doesn't cut the x-axis, so it's not a real root. Let me write that down. Not a real root. So that quadratic does not give us a real root, so the only root comes from x minus 3. So if we go down here, then the only root is x equals 3. That is the answer. This video has been far too long. I must apologise for that. See you on the next one.